So the first step you do is, and I'll walk you through step by step if you're using Orange. But before that, actually, I can do this also. I'll show it in Excel also before we break for tea. So look at that. 2412 instances. Now your new data file that we'll be sharing today evening, you will get a lot more. 19 features. It actually says 0.8% missing values already. Data has no target variable. Actually, this line, I've created a target variable, but let's see this. So my target variable, where was it? This is here. Yield tons hectare. I just renamed some columns. You had a similar file. I had a similar file.
There are temperature, humidity, and other things. Pesticide, days.
I had rainfall, area, hectare, irrigation method, soil type, region. This is some US file somewhere.
There are a lot more variables here.
Yeah, 19 variables: soil, fertilizer, pesticides, days to harvest, yield tons, storage days, transportation cost, market price, post-harvest waste percentage. This is the raw data file that I had. Okay, so let's go back. Then what I did was, the next one that I used was unique. I'm not saying you should use it. I'm only giving you a hint here. If there are duplicates, unique removes them. Okay, so I'm just saying, for all these variables, if there are any duplicates, remove them. In one shot, it removes. First one gone. Okay. Then what I do is, I actually used what is called an edit domain. Now, in edit domain, look at what I did. I mean, these are all nice to have. I'm not saying that you should do it, but there were some values, maize, which had a different spelling. Capital rice, I said rice. RCE, did it right. I've done some data cleansing. Automatic. Whereas on Wednesday, or rather day 3, I tortured you people. Use this spreadsheet, do this, do that, etc. Here, you don't have to torture yourself. I changed all these values. In one shot, I actually said, give me a clean set of categories. Look at what all was there. A wheat with a gap, a maize without an E, a rice which became capital, a wheat which became. So all these were merged. It automatically does all that the minute you say this is what I want. So like that, I actually did this for a few of these variables. These were all fine. The minute you click on region, it says, yeah, these are all the regions available, nothing to change. It didn't show me any errors. Okay? Now, impute. Where did we do impute? Same thing. Data handling, we did some degree of imputing. So, impute, what I used was something called model-based imputer. This is where it gets very interesting. Orange provides some really good ones. It says for each one of them, this is the default method, and for each one of them, you can click what you want. So for example, let's go to area hectares. Okay. Area hectares, I can say model-based imputer, or I can say random values. I can say district. This is what you all used. The average, the median, is what some of you or most of you used. It gives me all these, or you can put a fixed value. If you say fixed value, you can say default all those missing values to some value here, which is 5, 10, 15. Understood? So there is this impute button or impute widget, which you can use to actually do all the data conversions. After doing that, I did what is called a very simple data selection. You don't have to do it. but I wanted to try it out. So I said soil type is sandy. I can take it out, nothing wrong. I don't want to select anything. If I don't select anything, what is there at the bottom of that particular widget? 2400. You saw 2412 in the first one. There were 12 duplicates. You're getting a little bit tiring? No? 2412 observations. 12 observations were taken out because they were duplicates. Gave me 2400. Okay, so far so good. But I can select. I can say, for example, add a condition. I can just say crop type is rice. Can I do that? I can do that. Look at then what happens. Now you are playing with only 304. There are 304 observations for rice. There are 298 for wheat or something and so on. We can see all that. So if I say wheat, barley, about 303. Potato, about 298. So I picked rice. So now from 2400, I am playing around only with 303 observations. So far with me? Okay, good. Now it gets interesting. I am going to select columns. What columns do I want? Or what variables do I want? Huh? Yeah, so I want yield and I want rainfall. So I'm just saying, give me these two. So where is it? Yield is my target. Yield is my dependent. Fertilizer is my independent. This tool uses a slightly different terminology. It says target and it says features. What all features? Now, I know it's 4 for my colleagues, but this is a simple regression. So you have these two that I have selected.
So why fertilizer is independent?
Huh?
Why fertilizer is independent?
Oh, fine, man. You don't like fertilizer, I'll take it out. I'll put, what do you want, rainfall? Oh. Happy?
Why it is independent?
Huh?
Why it is independent?
Why is it independent?
Yeah.
Okay, if you go to the morning classes, I had specifically said, there is something that I want you to look in a data file and say, what is it that I really want to find out, or I want to be measuring, or I want to be predicting. In this particular file, I don't want to be predicting rainfall here. I am in the business of farming. If you are in the business of sales, you will be predicting sale value. So, for predicting what can influence yield, I am using rainfall to start with. Why? I am only looking at two variables to start with. If you have the energy and sugar levels at 430, I will take you into multiple regression. I can put literally all the other variables that are here. It becomes a multiple regression problem. I can put this, I can put this, I can throw all these remaining ones into this side. So measure this one against all of them. For now, I'm only demonstrating, this chapter is only about simple regression. Tiring, right? I know it's tiring. Can't help it. Let's look at the data. It is as good as saying from that particular spreadsheet, I have deleted all the ones that I don't want, and I have taken only 304 observations. Look at this. 304 instances, no missing data. Okay? One feature, one target. This is the target, this is the feature. The target will always be highlighted in gray. 1072.3 millimeters, I had a yield of 4.4 tons. That is what the actual data is. Okay, now in another 2 or 3 steps we will finish this whole thing. Now what I then do is, there is this aspect, then I build a model. Then I build a regression model, which is what I drag and drop the regression. But before that, what you can do is, there is this element of, when you build any model from now on, if you are given some amount of data, let's say it has got 100 observations. Out of 100 observations, you will take, the split is 70-30. You take 70% of the 100, which is 70 observations, and build the model.
So the independent is like the thing that we are going to calculate.
No, independent is just the opposite. Is this influencing? Independent is, I'm not predicting anything on the independent side.
But that should be the one that we are calculating, because it is not dependent on anything, so we are concluding.
Okay, what is rainfall dependent? Is rainfall dependent on yield, or yield is dependent on rainfall? Make up your mind. Who thinks rainfall is dependent on yield? So you have your answer. Your dependent variable is what? Yield. Rainfall is independent variable. That's it. So when you are given a file with 304 observations, because I have taken only for, I have taken it only for rice. I have touched only rice, so that's why I have 304 here, my dear friends. And then I have taken 70% of it to train the model. To say I am going to actually give 70% or 70 records to train it. It's a thumb rule. 70-30 is a thumb rule. There are also people who do it as 20 and then 10. 10 is considered to be unseen. Nobody has seen those 10 observations to really see whether the model is predicting very well. No outliers. You're not talking about outliers and all that here. You take that full sample, you split it into 70, 20, 10, or some people say 70 and 30. Then the remaining 10 or whatever it is, 5% will come from outside. New values. That's the model. Now, in business terminology, what does it signify? When you build the model with 70, the model would have seen 70 in its eyes. In your mathematics textbook, a particular chapter on calculus had 10 problems. In the class, I explained how to solve 7 out of the 10. So far with me? The remaining 3 I give you as homework. So with the knowledge of 7 questions that I solved in the class, you go home and solve the remaining 3 and try and crack the problem. The very next day when you come back to school, I will give you 2 new problems which you have not seen at all. At least in the homework that I gave, you would have seen the problem. It is there at the back of the textbook. But the 2 new that I am giving you when you come to the next day is things that you would not have seen at all. So now I say, now you know 7 plus 3, 10 problems you have solved at home. I am going to give you the 11th one. Can you solve it? That is the real world analogy. 70, 20, 10. Instead, if I say 7 problems, 2 problems as homework, whereas 1 you come back and actually write it on the board the next day. But you should not do it at home. Huh? Yeah. Okay. Now that is what I've done. Fixed proportion of data I have taken. You will actually see some new words here which I actually covered some time ago. It said stratified sample. Sample with replacement. Fixed sample size. I'll tell you all that later. Okay? Now, let's go to this and see the scatter plot. Did you also get the scatter plot of this nature when you did that? Somewhat like that, right?
Exactly.
This is for the sample data, which is 70%. Okay, this is the training data set. And look at this. Correlation is 0.64. There is a small r here, 0.64. I have plotted rainfall versus E. And if you look at this line, which is what this line is all about, there are some points on the line, there are some above and some below. Now, that's about it here. Then what I do is, I build a linear regression model. I just drop that and drag it here. Don't have to do anything, just keep it as it is. If you do that, the model produces a set of coefficients. Now, this is the way Orange will give you, but let me write it down. So rainfall versus E is that's the equation. Can someone tell me what is the business interpretation of this equation in business language? No technical language.
So if the rainfall didn't happen, it will yield 3.5 tons. And if the rainfall happened, it will yield that intercept plus 0.03.
I told you no more mathematical. Why is this intercept is not coming?
Directly proportional.
Math.
Still maths.
Business leaders, I go with them.
Can I try?
Please.
If it won't
There are two
rain,
statements I want you to make. If you know what to make these, if you call these two statements out correctly, you actually learned machine learning. I'm going to ask everyone, so you tell me. Two statements.
I have the rain, I have the rain, I have the rain.
मिलन दाई गूगल करता है
No rainfall, there is some. What is either rainfall?
mathematics.
Then,
Then 3 constant in
no mathematical terms.
3.5.
Okay, you're done. You? Same. Okay. You. Quick.
Second is same. First, I would just describe if it will rain this year, our yield will increase by 0.300313 times.
Okay.
सेम सर
Same what? Her or their statement?
स्टेटमेंट
These statements.
Yes.
You go with these two.
Yes.
You're not going to sign. Okay. There is a statement 3 that says if there is a rainfall, Then?
Our yield will increase
yield will increase. My handwriting is getting bad.
by
By
0.00 times.
0.0013. Okay. You.
Times
I
3.
want 25 statements.
ये वो तर times one मिले ना इतनी
तो जीरो पे the quantity जीरो पे
Okay. This one. Then 2 statements I said. What's the other one that you want to go with? So he said, higher the rain, higher the yield. If there is no rainfall, 3.50 ton of. Then she said, if there is rainfall, there is yield, something. Any other fourth statement you have? Which one you're going with? Okay. 1 and 2. We have so far how many? 1, 2, 3, 4 votes. Okay. Sorry? Okay, that is a fourth statement.
Based on expected rainfall.
Huh?
Predict the production, crop production based
ये
on
बंद कर दो ना
expected
ये
Okay. Predict something, something, something. That's the statement number 4 that she is making. I don't know if there will be a statement 5. I wanted 2 statements. She said something. Okay, good. You?
Rainfall is a variable that is affected. I mean, yield is a
mathematics.
No mathematics. This is a business language. I want only 2 statements, and there are only 2 statements which you will use from a business context perspective.
yield depends on rainfall.
Give me a break. 2 statements. Which one will you go with? There are already 4 statements there. You want to go with the third one. Okay, that is one statement. What is the other one? I'm standing between you and T.
second one.
Okay.
No rainfall.
4 votes to the first 2,
Okay,
2
sir.
votes to the second and third.
इसको कौन सा सुनो business को point of view. If yield is like a business, if you in the initial stage you have 3.5 something.
Okay.
If you have an investor, then you increase.
What's the next statement? Survival is all fine. Don't give it. Don't go there. Okay. Second statement. Rainfall makes profit. Okay, fine. Okay. Okay.
Even if there is low rainfall, we will still have some yield, and obviously the high rainfall will give us high yield. There is no such difference.
As the rainfall increases, the rain would be higher.
Okay.
Good numbers with take more to inflation.
Okay. Divyanshu, you told, right?
Yeah, I told
Okay. This is not a perfect mathematics class to say what is right and what is wrong. I have no idea why the AC went off. There are only 2 non-negotiable perfect business statements. In the absence of rain, there will be at least 3.5 tons of yield per hectare. For every 1 unit, which is 1 millimeter of rain, yield will increase by 0.0013 tons per hectare. Those are the only 2 business statements that you can fire. All others are invalid. Higher the rain, higher the yield. You don't have to say. That is called what? What did I write here? Before I erupted.
Correlation is not equal to causation.
I wrote counterintuitive. So what was there? What was the third one?
News versus views.
Views. By looking at this particular, why did it go off? By looking at this particular line, that is what it's news. The line is going up. So higher the yield, higher the rainfall, higher the yield. You don't have to say that. The minute R is greater than 0.01 or just greater than 0. Here it is 0.64 correlation. You don't even have to worry about it. You don't have to say that. That is news. So in this, then there is, if there is rainfall, then the yield will increase by whatever it is. Yeah, you're there, but it is like saying for 1 unit of incremental rain, because you are actually looking at greater than 0. 1 unit means 1 millimeter. The lowest rainfall in this axis is rainfall in millimeters. It's far out here, 0. If 1 millimeter rain falls, then 0.0013 is the incremental yield in hectares or per hectare or whatever it is. Happy?
I have one question.
Hold on, I've not finished yet. There's just one part. So the model has done this. What it has done, it has only done the 70 part of it. You gave it some data, I gave you 7 problems, you have understood 7 problems. What about the remaining 3 problems? You have to work out, na? You have to really work out. So this branch, where is my thing? This branch of orange tree that you saw, look at this. Sample data has gone there. Can you read it?
Yeah.
Not able to magnify it. Sample data, which is 70%, has gone into the testing and scoring. I wrote a linear regression. I said I've learned it. That's why it's called, I'm giving you the learner model. I've learned the model. I've learned 7 questions. I'm applying the 7 questions here. Okay? To what? The same 70% data, and it has given a set of predictions. Let us look at that prediction. Wow, look at that. Now, in orange, it gives the output like this. Rainfall is actual value here. Ignore fold for now. I'll explain fold in about 2 days' time. This was the actual value. 4.37 is the data that was there in the data file. I gave you the data file, or I'm going to give you the data file with 4.37. It's there. What the model predicted was 4.94. So there is some error. There will be errors. It will be high, it will be low. This is what it says. 4.61, 5.4, 5.71, 4.56, 3.72, and go on and on and on and on. This is for 213. 213 represents what? 70% of 304. Right. So, I have done the prediction based on the training data. So then, you can see this. It's a scatter plot for the training one. Then look at this lower branch here. This is remaining data. You see this text here? Can you all see? Remaining data. Remaining data is 30% of it. I am actually sending that also. Now if you double click this, sorry, not this one, predicted values. Predicted values for the remaining 91 instances. 5.7 is what the model said, actual is 7.42. So there is some differences there also. Now, if this is an important one that you have to learn, I have to take another 2 minutes. Let's see how many of you will do it tomorrow. It will be the most interesting part. This model carries certain degree of error. Okay, ignore this part for now. The power of the model is described here in what is called R square. It says 0.394. The business language for that is rainfall is able to explain 39% of the variation in yield. With only rainfall, I am able to only explain 39% of why yield is high or low. So in the morning when she was presenting this particular case, she had gone through several of these individual variables. If you recall how she was presenting, she was taking every other variable and then trying to see what is giving better yield. Rainfall alone, I am not taking anything else. I have not taken anything else in the model. Rainfall alone is able to explain only 39.4% of the yield variation. What else can explain? Something more.
Season.
Huh?
Season.
Go have your tea and come back.
Crop type.
Huh?
Crop type. Season.
If you add more variables, you will actually get better explainability of the model. Okay?
Okay, sir.
So we will see when you come back. So how 39.4 can work.